Hi, I'm Deepak Patania and you're on dArtofScience, where you'll see a lot of DIYs and experiments that show science creatively. Recently, Cuemath, an edtech company, partnered with us to create some innovative math content. So we thought, why not visualize mathematical concepts in a tangible way? So in each of these videos, we took a real-world problem and explained it through math. First in the regular textbook way, and then we explained it through our trademark hands-on way, which you can even try and should try at home. Maths and DIY? Sounds interesting? We present to you the art of math.
Oh look, I've drawn 7 shapes.
That's cool. I'm trying to add a little twist to my shapes.
How?
You see this square?
Yeah.
I tilted it so it looks like a diamond.
Oh, that's interesting.
Do you want to draw a triangle next?
Oh yeah, that's cool. Oh,
Can I have the red paint?
but I need the red paint. And what's that? That doesn't even look like a triangle.
Come on, it is a triangle. Wait. They're the exact same size. Let's just share the paint half and half.
Huh? How's that possible? Mine's so fat and yours is so thin.
Wait, look. See, the area of a triangle is half times base times height. Both our triangles have a base of 20 centimeters and a height of 15 centimeters. So using the formula, both our triangles have the area of 1/2 times 20 times 15, which is 150 square centimeters. See, both our triangles have the same area, so we should share the paint.
I don't get it. How is that possible? Can you show me?
Actually, let's do this the Cuemath way.
With this prop, we'll actually be able to see how both triangles have the same area. But before that, we'll have to first understand the area of different shapes. Here's a rectangle. If we tilt its vertical borders, we'll get a new shape, and this one is called a parallelogram. This happens with a square as well. The bottom horizontal line of a parallelogram is called its base, and the distance between the top and the bottom horizontal line is the height of the parallelogram. So how do we find the area of a parallelogram? For that, we can cut the shape along this height. So what do we do with this piece? What if I keep it here? Now that's a rectangle. Since we already know the area of a rectangle, we can easily find the area of a parallelogram. The area of a rectangle equals length times breadth. In our case, length is the base of a parallelogram and the breadth is the height of the parallelogram. Therefore, the area of a parallelogram equals base times height. Let's take this parallelogram and cut it in half diagonally. See, we get 2 triangles. Since we cut it in half, the area of each of these triangles must be the half of the area of a parallelogram. The area of a triangle is half into base into height. Now here we have 3 different types of parallelograms, and if we cut them all in half along the diagonals, we get different kinds of triangles. Acute triangle, right angle triangle, and obtuse triangle. Since all these triangles are halves of the parallelograms, they all share the same formula for the area, which is half into base into height. Mathematically, we now know that if triangles have the same base and height, their areas will be equal. But now, we are going to see it physically. This triangle has 2 flexible sides. These balls or beads represent the amount of area covered by the triangle. This triangle is the same size as both your triangles, with 20 cm base and 15 cm height. Now let's see what happens if we move the tip of the triangle along this line. This means that the height of the triangle remains constant. See, the amount of balls are shifting around, but they did not decrease or fall out. This means that this triangle has the same area. And now when I shift it here, you can see that the area still remains the same. If a triangle's base and height is unchanged, the area inside will be the same, irrespective of how it looks. In your case, both the triangles have the same area.
I knew the formula, but to actually see how these triangles have the same area was so cool.
Yeah, thanks to Cuemath, I finally understand the concept of area. Okay, you can have half the paint now.
Thank you.
So I was wondering, if a square and a triangle have the same area, would they have the same perimeter?
I don't know. Let's do the maths for it.